Ready when you are.
Thank you. Hi, everyone. Today, I'm going to be talking about React for Angular 1 developers. Yes, I will in one moment. So first, before I introduce myself, I just want to talk about a little bit about what I'm going to talk about today. So why React for Angular 1 developers? Because I've noticed there's a pretty vibrant community for Angular 1 developers in Minneapolis and actually around the nation for that matter. And I've noticed there's still a lot of new projects coming up for Angular 1. I know of a lot of bigger businesses and corporations that are still building new projects in Angular 1, and there's even side projects that people are still building in Angular 1. Angular 1 is a great framework, but I'm going to talk about today how you can jump into React and the tools that you need and the information that you need to be able to make that leap. I'm Tim. You can find my personal blog here. Object Partners also has a blog. I recommend you go and check that out. And you can find my GitLab here. If you haven't used GitLab yet, by the way, it's very similar to GitHub. And it has a lot of great features and allows you to do stuff like GitLab pages, which is where my blog is hosted. So why did I want to do this talk? Because I've been an Angular 1 developer for over 3 years now. And when I first made the jump into React, I struggled a little bit. So there's a lot of information that you need to know to make that leap. You need to know things around like state management. What are components? Do my components contain state? How do I manage dependencies? All that different stuff. And it's a lot of information to take in, especially if you're coming from Angular, where Angular, there's a lot more things on Rails for you. You have controllers that are attached to pages or views. You have services that help you share that logic between your controllers. So how do you do all of that similar stuff in React? And then also, I think this question is really important. Why? When you're talking about any framework or library, or really anything you do in development for that matter, I think that as developers, we should be asking ourselves this question more often, because it helps you get to the source of, why it is you're trying to do something, or how you're trying to solve it, or why you're using a specific framework. And then also, why talk about frameworks or libraries at all? Well, back in the day when apps were a lot less complex, we could just build plain JavaScript applications that did stuff. And if we never needed to go back and revisit that code, it didn't really need to be maintainable. Today, we have front-end applications that are very complex. They manage a lot of state on the front end. They have a lot of complex behavior. And so thankfully, we have things like Angular and React and Vue and Ember and all of those great things that help us manage that stuff. So I think this question of why helps us talk about what are the things that we need to help maintain our code and do a better job at creating complex applications. So I'm going to talk about a lot of the differences between Angular and React and give you some of the information you need to know to build an application. And then towards the end of the presentation, I'll talk more about specific libraries and things that you can use to start building your first applications, and then go from there. So the first thing I'm going to talk about is structure. Structure can be a lot of things. It can be as simple as the directory structure of your application. It could be things like how does your app hook up to the API and that kind of stuff. But it can also be things about how you just structure your pages. So I put together 2 projects for this presentation. The first one you can find below or in this slide. And this project has an API and 2 front-end applications. And the front-end applications do the exact same thing. They're just a to-do application. One of them is built in Angular and one of them is built in React. So I invite you to download this repository. You can do it after the presentation and take a look at those those two different front applications and see how they're doing things differently. And so I think this will help you kind of connect your Angular knowledge to what you will know or what you will learn about React. So we're going to first just take a look at the to-do page in this application and talk about kind of how we structure this page. So in React, in Angular, when we look at our designers' wireframes, we kind of think, how are we going to break things out into different components or controllers for our Angular application? For Angular, I think there's some fairly obvious things in here. We have our header controller and our footer controller that each manage the particular logic for those different parts. And then we also have our page controller or to-do controller that manages all of the logic in that area. We might also have a to-do service that shares some of the logic or moves some of that logic into the service that your to-do controller connects to. And that leaves us with 3 main controllers for this page. And then within our to-do controller, we'll do something like we'll repeat over our list of to-dos. So what we're going to do in this application is we want to be able to create new to-dos that have a title and a description, and then we want to repeat over them in a list and display each item. So today in Angular 1.5, you can actually use components, and they're similar to React components in a lot of ways, or how other libraries and frameworks are using components. But from my experience working with a bunch of different Angular teams, not a lot of people are using components yet. And so that's kind of why I didn't want to bake this into the slide, is because I think that more people in this room might have more experience not using Angular 1 components than people that do. Maybe I'm wrong. I hope I'm wrong. But we can see, so we'll end up with 3 main controllers here that ultimately control the logic of this page. You don't need to read this code. Oh, that's right, there's a delay. So what you can see here in this red box is all of the code that just controls that list portion. It's an ng repeat that goes over each item in our to-do list and then displays it, and also has the logic about what you should do when you click on certain elements in that to-do item. So on this chunk up here, you can see, for instance, we have an ng click attached to that little check mark that was in the top left of the to-do item, and it's calling a toggle complete method. So it'll toggle it on or off, or toggle it complete or not complete. And it connects that logic by calling the to-do controller's function toggle complete. And so it connects it by tc.toggle complete. What you've probably noticed if you're an Angular developer, it's sometimes hard to find this logic. You don't always know what that function is calling. So TC's in this case might be fairly obvious that it's the to-do controller, but that's not always the case in Angular applications. And so that's something that React helps alleviate a little bit, and I'll show you why later. Same page, except now on React. We're going to break this up pretty similarly. It's going to look pretty similar right away. We're still going to have a header component that's going to control the logic there. But we also break things down into smaller pieces. So we have our header component, but then we also have another component that falls under that just controls the navigation items. We have our footer component, and a lot of this is just static, or the stuff in the bottom here is mostly static, so we don't really need to break that up too much. But then we also have our to-do page component. And what we're going to do is, since there's so many things here happening, we want to break these down into smaller parts. And so this is just one area of where you're going to think a little bit differently in React versus Angular, is you want to break things down into the smallest pieces possible and encapsulate all of that logic for things that are happening within the smaller components themselves. So in the top part here, we have another component that's just controlling new to-do items. And then in the bottom part, we have another component that's just managing the to-do list. And we can break these down even farther. So in the new to-do items, we're going to break things down by their input fields and how we control the state changing just within the input fields. And then down in the to-do list, we can break the list down into to-do items, and we can break each to-do item down in even farther, just having one component that just manages the toggling of the checkbox, another component that just controls the description of the to-do, and then another one that controls the deletion of the to-do item. And so we end up with a lot more pieces to our application, but we encapsulate the logic. So it's a lot easier to find where things are happening and how they're happening versus React, or versus Angular, sorry. Yes. Yep.
I always struggle this time with UI development in general. It's like, single responsibility for like how far do you like take that? Like sometimes it's very hard to like at that point like find code, or you have to have like 30 files open and just like have a picture in your mind of what's actually going on. It's like, so that was one thing that was different with React. It's like so many various components. And I understand it from an extent, but then like I'm just kind of curious, like your experience, is you've obviously done both, and just I think and seem pretty experienced in both. Like, so I'm kind of curious how you like how that looked to you, like going that route where it's like everything you've got little tiny pieces and they all close together. You know what I mean? So,
that's a good question. This is kind of a cop-out answer, but not really. It depends. So it depends how much you break things down, but ultimately, the smaller you break things down into, I'm fairly certain this is true, the better performance you're actually going to get out of React because of how it manages the virtual DOM. And these are things I'll show later. Performance aside, though, I think as a developer, the thing you care about more than performance is actually maintainability of code. And
5% performance.
Yeah.
Like the stupid, like, oh yeah, my code's 5%.
Yep.
It's like, oh cool, I can't read your freaking code.
Yeah.
It doesn't matter, right?
Yep.
Yeah, sorry.
So no, no, it's a good point. So with React, the way you're going to be able to break things down allows you to follow the chain of responsibility a little bit easier than versus Angular. In Angular, a lot of times you have things where like events are being fired off and the logic for that event happens in some other service that you might not know until runtime. With React, when you break things down into these child components, you can see for children where or sorry, for parents, which children they pull in, and then you can follow that tree of children until you finally get to what you're looking for. And when you encapsulate the logic, you know exactly what's happening within that component, and you know exactly where the state is coming from. So I'll talk a little bit more about this later too, but the state always falls down through the tree of components. So I think the more you can break things down into as small of components as possible, the easier to understand your application actually is. Yeah. By the way, I forgot to mention, if any of you have any questions at all throughout the presentation, stop me. Like, I really want this to be a learning experience, and if if what you learn is based on something that you didn't understand earlier or what you could have learned, like I think that'll help the discussion. So feel free to stop me at any time and ask questions. Just raise your hand or something. Yes, Chris. Yes, sorry. He asked, how far do you take single responsibility principle? So how far do you really break things down? I hope that was obvious in my answer, but yes, I will repeat it questions later. And if I don't, remind me. Okay, so you saw kind of how I broke this down earlier, and versus the code that I had in Angular earlier, while sorry, there's a delay, I'm switching slides. So you saw in the Angular code earlier, while everything for that page existed in one HTML file, and I see this a lot on the projects I work on where everything is in one file. With React, you really want to break things down into smaller files. And so while there actually might be more code existing in these 3 different blocks for a single to-do list, the same exact stuff is happening here. So on the part on the left here, or on this block on the left, we have the actual list group that controls the entire list of all the to-do items. And then just the code for creating a new to-do item exists in this green block that's shown here in the middle. And then a single to-do item is shown in this block here on the right. Like I said, there's more code, but it becomes more obvious what it's doing, even though there's more code that needs to be written. And you can see that we break that to-do item down on the right even farther. So shown here by these gold boxes, we break down the checkbox and the description and the delete button for that to-do item down even further. One thing else that I talked about encapsulating logic and what the component's doing. So here, again, you don't need to read the code that's up here. You just need to follow along with the boxes. Is all of the logic is encapsulated in this component. So everything that's happening on that input field, for instance, with the green box here, it's attached to the onChange event for that HTML element, and the onKeyUp is attached to this red box here. All of that logic is stuff that's happening within the component. It's not calling out to any other service or any, when I say service, I mean like Angular service. There's no like React service that it's calling out to or anything. The logic exists within that component. And I'll show kind of how you can propagate, if you have shared logic, you can propagate this logic into parent components later. So now performance, and I mentioned how performance isn't that important, but I still think it really benefits us as developers to really understand why there's differences in performance between Angular and React and what that means. So the thing that's going to affect performance in your application the most is how does your application render the DOM? How does it queue events for things that are going to change in the DOM? And how are you going to control that? Thankfully, frameworks and libraries take a lot of the heavy lifting here. But again, I think it really benefits us to understand exactly what's going on. So I think there's really like 2 questions that surround this. And it's, when should I re-render the DOM? And how should I re-render it efficiently? And like I said, the framework or the library mostly controls a lot of this. But I think the question that we really want to concern ourselves with is, when should I re-render the DOM? And the answer is when your state changes. So what do I mean by that? Well, actually, maybe a better question is, how do you know the state in your application changed? How do I know what changed in the JavaScript portion or what's going on in the code? How does the DOM know that it needs to update itself to reflect some data point that's changed in your code? Well, there's 2 different ways that, well, there's a way that Angular does it, and there's a way that React does it. The way that Angular does it is through what's called dirty checking. So in Angular, we have this concept of scopes, where scopes define certain portions of your DOM and internal state that's held in that DOM, and then propagated down through children. And so all of for example, if you have a controller that's attached to an element, such as div, it's going to create a scope for that div, and then it's going to live in everything under it. And if you have other directives that create scope, it's also going to have scope that live under it. And so Angular has to do the heavy lifting on, when you change something on scope, re-render that onto the DOM. So Angular uses its concept of digest cycle to be able to do this. And I'm going to try to make this as easy to understand as possible, because I think if you've been an Angular dev, you've probably run into some issue with the digest cycle at one point in your lifetime. On the left here are examples of different directives or services that are built into Angular that automatically call the digest cycle through a function called apply or scope apply. So what happens is when you attach, for instance, an ng mouse over to a div element, and you mouse your cursor over that element, it's going to call that root scope apply function every time that that directive has noticed that you've moused over it. And so it could potentially call root scope apply 20 or 50 or 100 times in less than a second, and it's going to do this. It's going to, root scope apply is going to call root scope digest, and then digest is going to update the internal state of whatever's changed in Angular. And then it's going to call all of the scope watchers that are attached to scope for all of the children of root scope. So that's every scope that exists or that's active. Once that happens, it'll ask, is this the first digest site, or is this the first digest call that we've made? And since yes, it'll go back through and it'll call root scope digest again. So this means every single time that you call root scope apply, or some internal directive or service that already exists in Angular calls root scope apply, it calls digest twice. So digest fires at least 2 times every single time you call it. It'll update the state again, because state might have changed in one of those scope watch function callbacks that you've created. It'll call the scope watchers again, and this is how you can get stuck into an infinite digest cycle. And then it'll ask again, did the state change between the last time I called digest and this time that I called digest? And if it didn't, it'll update the DOM and finished its execution. 1 second, I need a drink. So how does React do this differently then? You can see that with the way that Angular does it, it can be at times inefficient. And so React uses the concept of virtual DOM to match in memory what's actually going on in the page, what the user actually sees, or what you actually see in your browser. And it uses this to its advantage to be able to create nodes in memory that match what's being seen in the DOM. So in order to create a node, and this is the actual stuff you can use to start creating something, is you call create component in React, or you extend the React.component class, and then it'll call the render method in that class that you create to actually render some element onto the page. Whenever you call the setState method inside of your class, it first updates the state for that class, or it actually mutates the state on that instance of that class. And it calls a method called shouldComponentUpdate. And these can be baked into your React component. And I'll show you how that's done a little bit later. But these are also methods that you should absolutely know what's going on when you start creating React applications. So when it calls shouldComponentUpdate, if you return false from that method, it won't do anything. It won't re-render that node. But if you don't do anything with it, by default, it'll return true, and it'll re-render that element for what it created when you called create component. So what this actually looks like on the virtual DOM is, on the left, you have what React is controlling for your state or for your DOM tree, and then what it's going to do here on the right side. So the yellow nodes identify what is considered dirty state, and dirty state is something that should be rendered. And then on the right is what's going to happen. So if on this far left bottom node, we call this .setState on that component that we've created, it'll call shouldComponentUpdate, and then it'll re-render that node if necessary. But if I call it for a node that's much farther up the tree and has many children that live under it, and when I say children, I just mean other components that fall under that tree in the DOM, it'll try to re-render every single node that's a child of that node. And so this is how you can, this is how it more efficiently renders selective pieces of the DOM, and how you can have more control over what it re-renders. So for instance, say with one of these child nodes, you don't want it to re-render. For some reason or another, you don't want whatever was updated in the state or passed down to it through properties, you don't want it to re-render for some reason. That'll be a little bit more performant, but also it helps you control what's actually updated onto the page, or what the user sees. So finally, what I want to cover, just want to make sure I'm doing good on time, is the concept of state, and how do we manage state in the application. I think before we get into how Angular does it and how React does it, I first want to cover the difference between mutable variables and immutable variables, because it makes a world of a difference coming from Angular into React. So mutable variables are just any variable that can be changed, and these are usually objects or arrays. By default, all objects in JavaScript are mutable. So if we create a new object that has the properties A and B, and then we call obj, which is the name of the variable, .a, and then assign it to a new string value, anything that pointed to that original object is also going to point to that new value. And so what this means is sometimes you have services that have an object as one of their properties, and it's being used by a bunch of different controllers in Angular. And one of those controllers could modify or mutate the state of that object, and it'll change in all of your controllers. And that sometimes can be a benefit, but a lot of times it can lead to bugs or defects in your code where things are changing when you don't expect them to, and they can be difficult to track down. So immutable variables are things that can't be changed. What this means is that they're more predictable. Once something is pointing to that object, you can have confidence that it will always be pointing to those same values that you originally assigned them to. So what you normally do in this case is, instead of mutating the properties that are on that object, you'll instead create a new object and then pass that object down back into something when it's ready to consume the new one. And really where this makes a difference is when you start talking about bidirectional data flow and unidirectional data flow. And Angular primarily uses bidirectional data flow, whereas React really preaches using unidirectional data flow. So for example, here in this Angular service, and I talked about this a little bit already, is that we have one Angular service that's being injected into two Angular controllers, and both of those controllers are assigning their own state property to the state object within a service. And if we have a button up here that changes that property in either of these controllers, when we call that, that's going to mutate the object back up in the service, and it's going to change that property, mutate that property, and it's going to be consumed by both controllers. And so this can lead to some unexpected things happening in your application, where you have a state that's changing when you're not expecting it to. So React solves this problem by using state and properties. So state is, you use this for stuff that changes within your component. If you have an input field where the value of the input field is going to change as the user is typing into it, this is an instance where you're going to use state. It's managed within each component that you create, and it's encapsulated in it. So state inside of a component is never going to be changed directly by another component. No other component is going to call, you know, this other component's set state method and change it directly. Also, with state, it should never be mutated directly. And this is where you get more predictable things happening in your application. Instead of mutating the properties on that state object, you instead call React's built-in set state method, and it queues changes that are going to be consumed by the DOM. And so it looks more like this instead of this. Props or properties are things that aren't managed within the component. So you never mutate the props property within your component. Instead, it's things that are passed down into the component. And so anytime you have state that's changing within a parent component and you want that state to be reflected in its children, you instead pass those things down through properties instead of, whereas in Angular, you would most likely use a service, and both components or controllers would instead point to the same service. An example here is when I'm calling the this.setState method within this handle change function that's on this form control or this input. So anytime the value changes, we call this.setState, and then for that target value, React changes the state.title property for you, and then it recalls the render method and redisplays everything else on the DOM. Now, I promised that I would help you build something in React if you had been an Angular developer, or that you would at least like know where to start. And I haven't really given you those tools yet. I've instead really given you the knowledge. So now I'll just talk a little bit about tools. And I don't want to talk too much about tools though, because you can create hour-long or even longer presentations on each of these things, because each of them have their own complexities and they all do their own crazy things. And there wasn't any really good way for me to fit this into the presentation to really help you. So first thing is, if you haven't used ES6 or ES7 yet, try it. Like, at least just go out to JS Fiddle and just try new features that are in it. I was working with ES6 for a few months, and I went back to a project for a client, and we're not using that. We're still using stuff that's pre-ES6, and I promise you I miss so many things about it. Promises, the spread operator, there are things that make your life so much easier. Default parameters for functions. They're great things to use, and you should at least try those things out. And it's also, if you're making the jump from Angular to React, that's a really good time to start using ES6, because it makes your code a lot cleaner and a lot easier to follow. Build tools, you'll typically see a lot of React applications use Webpack. Webpack is, if you're familiar with Gulp or Grunt in the Angular world, Webpack is the thing that's going to take over in that space for you. State management. These are things that manage state for your entire application. So if I'm talking about like my to-do list application, say I have my to-do list page, but I also want to display to-dos on other pages. You want to be able to manage those to-dos in a single space. And Redux is a state management library that helps you do that. There's also other state management libraries, but I think Redux is a good first one to check out, and then you can kind of make a decision from there about where to go next, if you think Redux isn't meeting your needs. Other ones that are out there, MobX or Flux. I think most people that were on Flux are either jumping to Redux or have already jumped to Redux, and I haven't heard anyone tell me that Flux is better than Redux. Transpiling your ES6, not all browsers support all ES6 or ES7 features yet. So if you're going to be using Babel to transpile stuff. Any routing, if you use UI router in Angular, React router is pretty much the go-to for routing in React, but Angular UI router also does make a UI router for React, so you can check that out as well as if you'd like. Styling, if Bootstrap is your thing, React Bootstrap is a good first place to go. Bootstrapping your application, so starting it from nothing. Before Create React App, this was much more complicated. We had someone in first React meetup, you'll remember somebody gave a presentation on Create React App. This makes your life 100 times easier. Use it. You won't even need to know anything about Webpack or Babel. It does all that stuff for you. It's a good first step. And then once you need to do more complicated things with your build, then you can eject Create React App, and you have a React app that has all that stuff already set up for you, and you don't need to think about it too much. And dependencies, you'll have seen in a lot of Angular projects, they use Bower. Or at least I've seen a lot of Angular projects use Bower. In the React world, just use NPM. All of your dependencies live in one space that way. It's easier to manage. Something I'm missing on here is testing. You can still use Mocha or Karma to do your testing, but React's go-to thing is Jest. I'm not a big fan of Jest, but you can try it. Otherwise, feel free to continue using Mocha and Sign-On and all of those great things. Yeah, I haven't actually tried Enzyme, so I can't speak to it, but I've heard good things. Okay. Okay. Yeah, so okay, so try Enzyme too. I mean, or check out Enzyme at least. Cool, so how do I actually build something? Tim, you've given me all this knowledge and information, I hope. So how do I actually build something? So I'm gonna go through here and just do a quick demo of just how to build something from scratch using Create React App, and how you'll create components and how those components will use each other, and how you pass properties and all that stuff. And so here's a look at what I'm going to build. It's just something really similar or real simple. We have some links to different things. You can see there's some commonality between how these things jump out. So we have a title for a link. We have a description for it. We have a home link for it. And then we have the documents that go to it. And then we should also be able to filter each of these things real quickly. Or if I type in something, it will just show only that link. Where am I? Okay. And I am going to cheat a little bit. Just to make the process a little bit faster. So first thing you're going to do is open a new terminal, and you're going to install Create React App. Yes, thank you for reminding me. Is there a better way to make text bigger? Can you guys read that in the back?
Bigger.
How big can I make it? Let's make it like 40 something.
There you go.
Hey. Okay. First thing you're going to do is globally install Create React App. I'm not going to run that because it's going to download the internet. And then you'll run Create React App and the name of your project. I'm also not going to run that because it will also download the internet and take forever. But pretending like I did run it, here's what you end up with, is a basic scaffolded out, I got you. is a basic scaffolded application that has very few dependencies. It has React and it has React DOM. A while ago, React separated these two things because they control different things, and React DOM is a very big library nowadays. It also has this React scripts dependency that lets you do things like start your server and eject and test and all that stuff. What happened to my... All right. Oh, there's some stuff running there. We can't see it. So part of this basic scaffolded app is you have an index HTML that doesn't really have anything in it. And you have your source folder. And in the source folder, we have just one component, app.js, or just app.js or app. And it's a class that extends component. So if you haven't seen ES6 yet or haven't messed around with ES6, this is maybe looks a little bit new to you. But it has one method within it called render, and it returns this JSX syntax, which is really just HTML, and you can bake some JavaScript into it. I'll keep it big. So the first thing that I like to do is create a new folder called components, and then separate each big component into its own folder. So we're going to move all of the stuff that's needed by app into its own folder. And then the index.js, which is the entry into your application that does this React DOM.render thing, it's going to render that app component, and so we need to be able to reach it. And so this is what I was talking about earlier with being able to trace where things are happening in your application. Using ES6, oops, we import different files. And so I'm rendering this app component. I'm importing it directly from here. You can see exactly where it's coming from. That's nice. So this is what it looks like right now. I broke something.
S components.
Thank you. S components. This is what it looks like to start with. Next thing I'm going to do is I'm going to create my sites components. So I'm going to make a new folder called sites because all of my sites components are going to live under it. I'm going to create a sites file. That's going to be the first component. Oops, I created a folder. It's hard coding in front of a lot of people. And then I'm going to write, by the way, I did this really quick. I'm using VSCode as my editor. If you haven't checked it out yet, it's pretty nice. You can do things like user snippets where you just write a few things and then it drops a whole bunch of stuff in there for you. And I've user defined this, so I set this up so it'll write this stuff. So I'm going to create an empty sites component, and it's going to render just this for now, which is nothing. I'll write hello in it so we can see it on the front end. And then I'm going to do this for all of my other components that I need. And by the way, here's the components that I think I'm going to need. I'm going to need one for a filter input, so this input field. I'm going to need one for my title. I'm going to need one for the description. I don't really need that. I mean, I'm really breaking it down into a lot of things just to kind of show you how it works. And then I'm going to need one for my links. So I'm going to create just empty ones for now. I need a site list. I need a site header. By the way, you'll notice I'm not using any semicolons. I stopped using semicolons a while back, and I really like it. And I'm back in a project where their ESLint defines that we should use semicolons for everything, and I hate it. If you haven't tried it yet, just try it. If it's not necessary, then it's my opinion that you shouldn't write it. It's just one less thing you need to worry about.
Let's say you can't have something.
Mine does. Yes, for any projects that I create, I tell myself I'm not allowed to have semicolons. Oops. I'm gonna my filter input. And then I'm going to need site data. I'm just going to create a JavaScript file that has that in it. Actually, I'm going to cheat. I'm going to jump ahead. I can't even see my own terminal window. This font is so big. I just jumped ahead, so all this stuff is already created for me. So I have my sites component. There's nothing in here yet. If I put something in here, it'll display on the page because my app component is going to call it. Whoops. It's putting a div under a paragraph. That can't be right. So here's the path of how I can follow what's using what. I'm importing sites from this sites folder, this component, and this file is exporting sites, this component. That's kind of how I can follow the path of what's going on. And so I can see in this app, now I have hello is being rendered here because it's looking at the sites component. So what I really want to do is list all of my sites under here. So I'm going to have a sites list or a site list. And I'm going to pass down a list of sites into it. And I'll show you where this state comes from in a second. You can see there's nothing weird going on here. It's just JSON that holds some data about different sites. I'm going to import the site list. And then I'm going to add the constructor method to the component. Now React dictates that you must call super.props in your constructor. And then I'm also going to initially set the state. This is the only time in your components that you will ever call or that you will ever use this.state equals something. So I'm going to use this.state equals sites and it's going to get that from the sites data file. Also, this is one other cool feature that was added in ES6. I don't need to call sites equals sites. Instead, I just call sites. And it automatically sets the property of sites to this. Now I'm passing this down as a property. So the site list component is going to get the site's property. I don't need that there. Okay, so now I want to, in my site list, display a single site item for every site that it gets in properties. So in order to do that, show you where this is coming from in a second. So JSX in React allows you to use normal JavaScript stuff baked right into your HTML. And what's nice about this over using Angular directives is Angular directives are a very proprietary thing. You need to know that an ng mouse over directive exists in order to use it. You need to know that there's an ng repeat in order to use it. In React, you just use plain JavaScript to loop over something. So I have I have the sites property that's being, if you remember, is being passed down into site list right here, and I can loop over it using for each site. And then this is the arrow notation that's also added in ES6. I don't need this. I need this. So for each site that's within this array, it's going to display a site item. And then the site item is going to also call in a bunch of the other components that it needed. So it needed a site header. It needed a site description. And it needed site links. I'm going to jump ahead here so we don't run out of time. Step 3. Okay. So you remember I passed from the site list. It's passing down the site for each site that exists in this array down into site item. Site item is getting it as a prop or a property. And then for each site item, it's going to display the title from the site prop, the description, and the home page, and the docs links. Or it's going to pass those down into the site links component. And so if we take a look at like site header for instance, it's just displaying the title prop that's passed down into it. And the links has 2 properties, homepage and docs. If you remember, they come from here, homepage and docs, and display those things. And so what we have so far is this, is it's iterating over each site that exists by just using for each, and then it's rendering each site item component. And every time one of these sites changes or the site's data changes, it's going to re-render, if you remember, it's going to re-render that entire tree of the children that do change. Now the next thing I wanted to do is I don't think I'm going to really have time to jump into it. He asked if I'm going to, yeah, he talked about if I was going to talk about should component update. And so, yep, I could, yeah. What I added here in step 4 is in the site filter input, I wanted to show some things around different logic that's going to exist inside the component. So we have this filter thing, and every time I change it, it's going to call this onChange event in the input or in the HTML input, and it's going to call this function, this.handleChange. This is bound to this component, so it's going to call this function. It's going to, for each props, it's going to call the onFilter input that's passed down into props, and it's going to pass this value to it. This onFilter input function comes from sites. Yep, so sites is the parent component of site filter input, and it's passing down this function that handles the filter input. And it's also passing down the text that's being displayed in the input. And the reason why it's doing this is because the state of sites, set to filter text, needs to be able to not only update the filter text here so it can send it down into site list later. I'm just going to jump into that right now. So it can pass the state of filter text down into the site list component as a prop. It needs to be able to set that state here. So every time I call, or every time I change the value in the filter input, And I can't type at a lectern. You can see that that method is being called. And this is really efficient because it tells React, it tells React to update specifically when you tell it to. It tells it only to re-render when you call that that state, and then every time it does re-render, when it calls this function, it passes those new properties down into the site list here. And so that filter text is being passed down into site list, and then site list, because it's a child component of sites, is also being re-rendered. And therefore, it can compute the new value of what visible sites should be looped over and then displayed as a new site item component. I could add the should component update method in here. And if I returned false for some reason, then hypothetically, this list should never update. So even though I'm passing in gibberish into this filter input, it never updates the site list because in site list, should component update returns false. So I think what you can take away from this, I mean, I know stuff like this is harder to follow in presentations, is you can go and download this repository and the to-do list one. The to-do list one also has the Angular version of the to-do list built into it. You can go download those things after this presentation and go and look at them yourself and play around with it and see exactly what's going on. Also look at the React docs and like actually sit down and read them. They're very good. They're very thorough. And they cover a lot of different use cases for weird things that you need to do that you wouldn't expect to know how to do. I believe that, yeah, so that's it that I have for the presentation. Any questions to end on? Yes. There is no difference. That's what you use if you want to use ES5 with React, and extending the class is what you want to use if you use ES6. He asked, what's the difference between using the React, I think it's create class method, versus just extending the component like this. Stateless functions, yes. I wanted to cover that. Unfortunately, I didn't have a lot of time. Stateless functions are components that don't maintain any state. So yes, I think it was easier to intro with how to create a component and not really worry too much about that. Using stateless functions is one thing you can do in React to make your components a little more obvious as to what they're doing when you first look at them. And there's also performance benefits to doing so. But they're things you don't really need to worry about right away. But it's something you should eventually understand.
So you did mention in your tools and libraries, you mentioned Redux and state management, another possibility was MobX. And obviously this was a very simple demo that we just ran through, and you're using this .set state, which ships with React. Do you have any recommendations on when you feel like you should be moving away from this .set state and into a state management tool?
Yes, I think Nathan asked if when should you move off of using this .set state to manage all the state within your components, and using something like Redux to manage the state across all of your components. So I think if you're a beginner to React, try to make things as easy for yourself as possible. Don't try to swallow the ocean, and use all of these tools right away and try to use them all together, because you're going to make things more complicated for yourself. If you really just start with just pure React and just build something super simple that doesn't do that much, you're going to understand what React does. And then you can start incorporating other things. Like you can start incorporating Redux to manage state across your entire application. And what Redux does is really make that unidirectional data flow a reality for giant complex web apps, where you have really deep children nodes within your application that pass some object or state all the way up to Redux, and then Redux is going to take that thing and pass it all the way back down through your application. But I would say don't jump into that stuff right away, just because it'll make things in your life more complicated for you. But they are things that you will need to know eventually.
Go ahead, John.
This is too Minnesota.
Oh, well, it's basketball. No, I was just wondering, so just along the lines of that, like but you know, if you don't use Redux, you're like doing all this moving functions around, like shipping functions around this thing we want.
Yeah, it can be. Yes, I mean, if you're not using Redux, you're just gonna make life harder for yourself when you're passing functions around. That's why I think, like, if you're an absolute beginner, just start with Redux or just start with React and just build something super simple. Once you have any sort of application that represents any sort of state that needs to be used by different parts of your application, you will need to start using Redux or some other state management tool like MobX or Flux to really manage your state for you. And I think if you have something starter that you're building that you keep trying to like pigeonhole different external functions from like utility files and stuff, then that's probably a good time to start trying out something like Redux.
Sorry.
Yep.
Frameworks like the C# that have concepts of bubbling up
Mm-hmm.
like that. From what I'm looking at here, it's more changing the state properties instead. Is that true, or is there any concept of moving event handling?
Yeah. Yes. Is there any sort of like concept of moving events around and stuff in your React application? Did I capture that correctly? There can be. I mean, you typically want to stay away. It's my opinion anyway, that you want to stay away from using events that propagate different information to different parts of your applications in React. And things like Redux or any other state management tool is going to, I think, cover your bases pretty good on moving state around in your application. For propagating stuff up, though, like from children up to parents, that's really where props come into play. And whenever a parent needs something to be passed from the child up, that's when you pass a function down into the children, and the children will call the function and pass the parameters of whatever data needs to be changed, and that'll go back up to the parent, be called, and then the parent can do whatever it wants with that information. And so that makes the reason why that's the right way to go is because it's then very obvious to follow the path of what's happening to your data. Whereas if you're using events more often in your front end code, or really, I guess any code, is you don't always know what's being hooked into those events, and you won't need you won't know until runtime, at least until something that's listening to that event is called. So it's just a lot more difficult to debug and follow exactly what's happening to your data.
So title of talk, React for Angular 1 developers, coming from Angular 1 into React. What was like your number one like gotcha or something that was like, what made it click? Like there must have been when you first started, like, well, I'm not sure if I get this or something that just sort of tripped you up.
Yeah.
Anything like that?
Nathan asked what's my first real gotcha moment that I had in React that like really tripped me up as far as what was happening or what made things click. I hate to keep coming back to state, but I think state management is really what did it for me. Once I started using Redux and actually understood what the hell it was doing, that's when things really clicked with me on being able to follow the logic of an application and just exactly what's going on. I can't think of anything else that really like outside of the presentation that really clicked for me. I would say maybe breaking things down into smaller components too is really something that stuck with me coming from Angular.
For me, it's a little bit more simpler now. There's no ng transclude.
There's no ng transclude, yeah. Yeah. Something that also really bugs me about Angular is when you have run and config functions that are called. I've seen in a lot of different big projects where there's run and config functions that are just called from some mysterious file somewhere that you don't know what the heck's going on or where it's coming from.
I struggled with that. I had to
Yeah.
drag and drop application HTML files, and it was just I used directives to and then the functions that they call it injecting events all over the place. You can't really see one file. Here it's just the loop with the actions you're passing to the prompts and everything. This makes it much more nice flow.
Yeah, there can be some real gotchas too with using scope within directives, whether it's isolate scope or whether you're sharing scope with something. And I don't know enough about Angular 2. What do you know?
Yeah.
Yeah. Okay. Any other questions? Cool. Well, I think there might still be pizza back there. There's at least beer. So feel free to hang out and talk, and thank you all for listening. Thank you.
So that's what we got for tonight. Again, we want to thank Object Partners for hosting, the place, the beer, the pizza, everything. Yay, Object Partners. As far as Object Partners goes, we